Okay. I'm going to talk a little bit about Forth applications and when Forth is useful. And I'm not going to really talk about when Forth is not useful that much. This is a joke, actually. This is a toaster that you can talk to over the internet, and it was at the BSD booth in a Unix thing. And I don't think that's a practical device, but the thing I wanted to bring across is that Forth is going into lots of things, and some of these things are things you wouldn't expect microprocessors to be in. A toaster being a prime example where you wouldn't expect a microprocessor to be in it, and actually probably doesn't belong in it. But on the other side here we have robotics, and I'll talk a little bit about that, a bit more about that. Okay. Yeah. Whoops, I went too far. What's backwards on here? Yeah, I don't want to. Yeah, there you go. Okay, I was having my finger is much larger than the button here, so it wasn't doing too well. Okay, this is really an artist's conception of a Android. It's funny. You look up Android on the internet, and all you get is a phone. You don't it takes quite a while. So I had to say humanoid robot instead because, and I got this artist conception, and I kind of like her, so that's one of the reasons I brought her here. What are you doing to me?
Sensor. I thought I was just plugging in the tower.
Okay. Well, while that's not on the screen, I'll talk about it a little bit. One of the things I'm interested in is the interfaces between standardizing interfaces between ARMs and various. So you can have pluggable appliances for a humanoid robot, or for a human that has lost arms and legs and limbs. And really, you don't need much. All you need is a fiber optic cable and a means of getting power to a limb in order to have a lot of control in the limb for the various fingers and so forth. And you can send messages through the fiber optics. And so it shouldn't be difficult to make something that's standardized for both humans and for androids when androids come into being. And they're already here, actually. Japan seems to be the pioneer in that area. How are we doing?
Plugging in power, the laptop thought I wanted it to reboot.
Okay. So.
Shut down, as we like to call it.
Okay. Well, I'll just sit here and talk then. I'm just curious. Of the original 12 apostles of Bill Ragsdale and setting up Forth for the various, how many are here? 1, 2, 3, I think I see. Did I see another hand over here? Okay.
You mean on the implementation team?
You're on the implementation team, yeah. Yeah, I was. Is Kim Harris here? No, okay. He's the one that talked me into joining that team, and it was a lot of fun, and that got me interested in Forth. I was interested in just writing compilers and that sort of thing, so I thought that'd be a good exercise. And then I got hooked for a while, and then found out that wasn't a way to win in the job market, and so I did a few other things.
This is the Microsoft moment. At the beginning of almost every presentation.
We were not talking about standardizing mechanical interfaces.
Yeah, true. I mean, the idea would be that all the mechanical stuff is in the ARM, and there's intelligence in the ARM that just gets commands from some a CPU that's somewhere else. And there's a an MPU in the ARM that takes care of all of the decoding of those commands and so forth. That way, you don't need big cables running down to the ARM. You just have the fiber optic cable that handles everything. And I mean, the world's gone to distributed processors, so you might as well distribute them, I mean, they're cheap. You were talking about $1 for a processor now that you can put forth on. So it's not an issue anymore. Mechanical arms are very expensive. And as they're finding out, because they need quite a few of them for our combat troops. I think we're in. Okay.
Sorry.
Okay, let me go to the next slide here. All right. There we go.
That and say next slide. Next slide.
There you go. I think I'll do that. That button's so small. My thumb is, that button are not compatible. Okay, this is a camera, believe it or not. It has 5 processors in it. This is an SLR. This is an old SLR actually. It was in the 1980s. This came out in the late 1980s, and it's the F4 camera. It has it's a film camera actually, so it has a motor for film advance and all kinds of stuff, and autofocus and a number of other things. And so there's CPUs for the lens, CPUs for autofocus. There's a main CPU, a display CPU, and a rangefinder CPU. So all of these things operate this camera. This was actually quite a popular camera, I understand, for high-end photographers. It was an expensive camera. But it just shows you how just in a camera that there's five processors in the camera. The distributed processing has come of age as not just now. It started out in the 80s, in the late 80s. But in situations like this, these are tiny CPUs, and generally with enough memory and so forth, so you could implement forth on them, and so that you could actually do forth implementations for devices like cameras and so forth now. Next. Okay, microprocessor requirements. Generally, all you need is, I'd say, 8 bytes of ROM and 256 bytes of RAM. Lots and lots of processors around here that have that now, of the MCUs. And the forth interpreter itself is generally, you can fit that into 4K bytes pretty easily. And then I'm saying another 4K bytes for whatever the program is that's operating, whatever it is you want to do, and a small amount of RAM. You need more RAM if you're doing for development. One of the things that is problematic, there's a lot of forth that they have on microprocessors where you can't do forth on the microprocessor itself. You have to do it on another machine and download your thing. And they really, one of the great aspects of forth is interactivity, being able to change things on the spot and do stuff, and not have to go through a cycle of compiling, downloading, and so forth. So I like the idea of having the target processor be also your machine that you can do your implementation on. If forth I'm sure has been done on machines with less than 16-bit addresses, but 16-bit addresses, at least 16 bits is preferable. But they've had forth on machines that have relative addressing of only 256 bytes, like the 8051 and that sort of thing. And I don't know. To me, don't use those things anymore. I mean, they're cheap, but there's a reason for them being cheap. You can get 8051 now for 50 cents, but I'll spend $1 and get something that's got a little bit more capability. Next. Okay, here's the application space that at least I see, for robotics instrumentation, diagnostic processor, keyboard processors, appliances, lighting control, motor control. These are areas that I'm familiar with. I've implemented stuff in Forth, which is, I would say nowadays you don't want to do in Forth. I did a big database system, a very large database system in Forth, and there's MySQL and all kinds of other things around now, so you don't want to do that. So the other thing is, I guess the point I want to make is, if there's a very large library of stuff around that you can use with a particular language, and that's a useful library to implement what you want to do, use that language. I've programmed in well in excess of 30 different languages, and I use the language that suits the application, and these are the applications where I would prefer to use Forth. Next slide, please. Okay, here's some of the things that I've been involved in, either directly or indirectly. One was Finnegan Instruments had a gas. It's a chromatography and mass spectrometer combination device. I don't know. I only did one small thing there, which was the NBS search, library search part. And that was very interesting part of that is I was able to try 3 different algorithms for the NBS search in a very short length of time and find the one that was the slickest one, the fastest one. But what the NBS search is, you go through the National Bureau of Standards library of spectra, and you match up spectra for various compounds, and so you can find out which one matches the thing you're looking at. And anyway, it's a mass spectrometer, not a mass spectra, not the light spectra you're thinking of. Might be thinking of. I don't know. Finnegan's out. It got bought by somebody else, and I don't know. I don't remember who bought it. But anyway, the interesting part of this thing is the mass spectrometer was the NBS search on ANOVA, which was written in machine code, took a certain length of time, and I don't know what algorithm they were using. But this instrument, that particular one sold for $200,000, that mass spectrometer. This one was selling for $50,000, and we beat the hell out of the General Nova one, which was embarrassing to them, and because they wanted to still sell their $200,000 instrument. So from what we did is there was a little piece of code in there that we turned into machine language, which is right in the internal part of the loop of going through the spectra, and that thing just went whiz bang. It was really fast. It was on a 286, so it just wiped the Nova out. But anyway, that was. I don't know what they did afterwards. I think they slowed it down, but I'm not sure exactly how they did that. Then another one was a ski lift motor controller. Here's a little Z80 that was controlling these huge motors that were they're 500 and 1,000 horsepower motors that drive ski lifts, and so they do it through these hockey puck SCRs, and while I was there, one of the hockey puck SCRs blew up. I guess because it had it hooked up backwards or something, I don't know, and it actually blew a hole in the metal cabinet that was containing it, and the guy was standing next to it, and he lost his eardrum, and so that wasn't due to the Forth at all. The Forth had nothing to do with that. But anyway, all the control of that was done on Forth and a Z80. Another one was a Windmill energy monitor. This was done on an Apple II, interestingly enough, and in fourth, and it was to display a bunch of characteristics of a PG&E windmill to see what was the their, you know, how fast the wind was blowing at various times of the day, and temperature and and power generation and so on. This other one, this was the appliance energy usage monitor. This was actually done in machine code. It should have been done in fourth, and but this was done. This is a company called Logical Services. It used to be in the valley here. Logical Services was doing this for Southern California Edison. The problem was we got the thing running. We had essentially air conditioner controller that would change the usage of the air conditioner depending on temperature and other stuff. Refrigerator controller that would make the refrigerator do its heavy duty time during off hours when the power was less expensive, and there was a couple other things like that. And then there was the power meter itself. We had a modified power meter, which would do the. This was long before the PG&E power meter that's going around today that does the rate change stuff. And anyway, this was all done through the power line. There was power line communication between the household devices and the power meter, and so they would all talk, and you would be able to get a whole printout of your power thing if you wanted it of your power usage in your house, and what was using what and so on. So the problem was that this was presented. The whole thing was set up and shown to the board of directors at Southern California Edison, and one woman got up, one of the directors, and said, "We don't want to do that. We want to sell power. We don't want people to save on energy." Project over. So that was that. Okay, theatrical light controller. We didn't. The company I was involved with didn't do that, but this was one that I saw. It was if any of you remember the old theaters where they had the big rheostats with levers on it that you control the lights in the theater and so forth. Well, this was done with SCRs instead, using a Z80 processor and a little display, and then they have these little things that you see on the boards that are used by audio people, you know, with a sliding bar rheostats. And so that was, and then later on, there is another thing where people had these lights that had a microprocessor in it, and the light, you could control the light from a computer, a laptop, and they would have an iris that would open and close so you could get the broad and change the width, beam width, and also it would change color filters and stuff like that. And so you could, from a PC, you could control a whole bunch of these, and each one had a little processor in it that had forth on it that intercepted commands and did its thing. Now, one that many of you are familiar with is the boot ROM. There's lots of companies that had boot ROMs in their computers that had forth in it. And this was really a great application for a number of reasons. That was, I worked for Intergraph, and that was the first company where I realized that they were using forth in a boot ROM. And then I went to Sun, they were using it, and Apple was using it. I worked for all of those companies at one time or another. And the neat thing about it, and I really saw this in action, there was a guy that was called in from Texas because he was an ace guy that could find faults in new silicon. And we had a fault in our new silicon, and nobody knew what it was. And so he came in, and he started writing little forth loops using the boot ROM and looping through various things, and found out that there was some crosstalk. If you sent a certain pattern, you get some crosstalk between a couple of wires inside of the processor. And This was actually a North Bridge on an Apple North Bridge, which talks to memory and talks to the South Bridge and talks to the processor. I guess it took him about a half an hour of fiddling around in Forth before he found the problem. And there was really no other tool around where you could do this. And this was very handy. It was very easy for him to just make these little loops and go through and find the problem. And find the exact pattern. And as soon as he found the pattern, then he knew which bits were involved, and he knew where to look. And by God, then we got the piece of software that should have told us this in the first place, which was the one that gave you all your crosstalk parameters for a chip. It goes through. They didn't want to pay for it. Well, after the fact, they paid for it. Yeah. So it was a thing that analyzes crosstalk and chip designs. So okay, next slide. Okay. Now, if you want to put forth on a new processor, of course, the way to do that generally is either do the primitives yourself, which is the way I did the first implementation. You just code somewhere between 12 and 30 primitives, depending on how efficient you want your Forth to be, and then the rest is all in Forth, so you're ready to go. There's a lot of metacompilers that help you do that. The other thing that you've seen today is you can also use C, C++, and Java to do a transplant. The thing you got to be aware of there is if you do it in C or one of these other languages, you don't want to bring the library with you. You just want the C code. The library will fill up your ROM really fast. And there's lots of machines that have Forth on them right now. One of my favorite processors are the PIC 16 series. I think they're really nice little processors I happen to like. And maybe I just like them a lot because I'm familiar with them. And I had a bad experience with an ARM, but no offense to the ARM person that was here. But it was actually, ARM was overkill for a particular project that we wanted. But anyway, that's basically it. I think that's the last slide. One other thing I would like to do is ask around a little bit. Anybody have some things that they feel that they should have added to my list of applications where you think Forth is a really good fit?
Well, not adding, you did show being able to do diagnostics. Could you do something called IPMI, to be able to measure temperature, voltages, things like that. And all it has to do is just go out and measure like a thermistor or a AV. Just keep doing that around and around and around. Then when you query, like what's the temperature near this FPGA, return it.
Right. Yeah. Or you.
Instead of just, I've had places where they've done this using H8 running Linux.
Yeah. You're talking about a diagnostic processor which is on the board with a bunch of other stuff, and it looks at the temperature. Right. Right. Yeah, actually, they've done that at both Apple and Sun too, as well. Not necessarily in Forth, but that is something that is a good example for Forth. Any others that you can think of that are yeah? I know people that are using C and Java for that, but not Forth. I mean, it probably is. It might be a good idea. Yeah.
An awful lot of research projects, because you're typically concentrating on machine control and then data back.
So instrumentation and kind of right. Instrumentation is a very very good area. Yeah.
intermediate thing runs with F-code. Sparks F-code you can plug in these intermediate file things that the open file would be.
Okay, I'm not familiar with that.
It's like a fourth source in numbers. So you plug a I/O card into a sun,
Mhm.
and the driver for the card was an F-code program that would get.
Oh, yeah, they do the same. Okay, now I understand what you're talking about. Yeah, they do the same thing at Apple, where it would go around and it would look and see what peripherals are attached, and make sure that it was talking to it and said, okay, we've got to have the right driver for that guy and so forth.
Driver off the card,
Yeah.
dials it because it's an
Yeah.
intermediate.
Yeah. Okay, that's one step above what I was thinking. Okay. Are you familiar? You're familiar with that, John, right? Yeah. Where they. Yeah, you'll go around and it would pull in the code from the devices, or would they would have the code and they just decide that the device was there, identify it. That's all it did. Okay, yeah.
You could do both. You could have a
Yeah.
file business system,
Yeah.
or you could collect it from the plug-in card from its own launch app.
Okay. Yeah.
You mentioned driving motors with Forth, a particularly popular application. Anybody remember Hardtronics? Mr. Martin, his bit slice, Forth engine. Okay, it's the hand in the back. Anyway, back in the early days of Forth engines, the very first dedicated pieces of hardware was actually sold, if you look through old Forth dimensions. The real ones, not the ones with the excurvated pages with no ads. Or programs for Forth days, you'll see this bit slice, AMD based, Forth engine, next Forth engine. Anyway, that guy has since written an article in the last +1 issue of Forth Dimensions about using Forth to design FPGAs and hardware to drive stepper motors and on micro-stepping mode. He has very sophisticated motor driving, and he just recently, I was flipping through one of the trade publications I occasionally look at, and there was an article by this guy. So he's still in business, he's still selling micro-stepping stuff. I assume there's still Forth in it, but he's too busy, thankfully.
Did you use it?
I'm not really sure whether it worked or not because my voice is so loud.
It's for the camera.
Gary, could you pin it off?
Oh, yeah. That was my fault.
Then after
Thanks.
Sandy's talk, we're all going to mosey on down and have lunch. But before you go, pack up all the stuff that's on the tables, because the tables will be migrating to the perimeter of the room for the festive green arrays buffet that we will partake of after lunch. It won't be a buffet of food so much as a buffet of knowledge.
All the tables are going to be moved?
Many of the tables are ready to move. So you pack up your stuff. If it's here, it may be someplace other than where you left it when you get back.
And is there a place to put the stuff? Or are you going to take everything with you?
Well, you
Can you
put it
can
in
you
the
see
front
see
of
the
the
thing?
room or behind the front of the room,
Back of the room?
in the back of the room, outside the hall. You can
Hey, Mr. Jaffe, can you see the the Swift?
Yeah, it's like a couple pixels.
Well, zoom in a little bit. You know, I don't have anything up here.